Welcome back to Infigyan, my dear friends. In this video, we are having one very interesting question from trigonometric Diophantine equations. Here we have to find out positive integers where n cannot be equal to 1. If given equation is 1 over sine pi over n equal to 1 over sine 2 pi over n plus 1 over sine 3 pi over n. So let's get started. I will take this term to the LHS. So I can write our equations LHS as 1 over sine pi over n minus 1 over sine 3 pi over n. This will be equal to 1 over sine 2 pi over n. Now I will take LCM. So I can write sine 3 pi over n minus sine pi over n divided by sine pi over n times sine 3 pi over n, and RHS will be 1 over sine 2 pi over n. Now in numerator, we will apply sin C minus sin D formula. So let me write here sin C minus sin D. It is equal to 2 cos C plus D by 2 and sin C minus D over 2. Let's apply. So I will write here sin 3 pi over n minus sin pi over n divided by sin pi over n times sin 3 pi over n equal to 1 over sine 2 pi over n. Let's apply 2 cos C plus D by 2. So 2 cos by 2 is here, C plus D. So 3 pi by n plus pi by n. Now sine C minus D by 2. So by 2 is here. And here I will be writing 3 pi by n minus pi by n divided by sin pi by n, sin 3 pi by n equal to 1 over sin 2 pi by n. So if I will add these two, then 4 pi over n, half is outside, so it will become 2 pi over n. So I can write 2 cos 2 pi over n. Here I will be writing sin 2 pi over n and half is there, so pi over n. In denominator, sin pi over n, sin 3 pi over n, RHS is 1 over sine 2 pi over n. Now sin pi over n, sin pi over n will be over. Now I will cross multiply. So I can write 2 cos 2 pi by n sin 2 pi by n equal to sin 3 pi by n. Let us write 2 cos 2 pi by n sin 2 pi by n equal to sin 3 pi by n. Now 2 cos A sin A or 2 sin A cos A, it is equal to sin 2A. So this formula we will apply in LHS. So our equation will become sin 2 times 2 pi by n. It is equal to sine 3 pi by n or sine 4 pi by n equal to sine 3 pi by n. Now I will write general formula for sine. If sine theta equal to sine alpha, then theta will be equal to k pi plus minus 1 raised to the power k times alpha, which I will apply to our equation in the box. So let us apply. I will write 4 pi over n. This will be equal to k pi plus minus 1 raised to the power k times alpha. It is 3 pi over n. Now I will consider two cases. When k is even, then we can substitute k equal to 2m and k is equal to odd. Then we can apply k equal to 2m plus 1. Let's apply. So I can write 4 pi by n equal to, I will be writing k pi plus minus 1 raised to the power k times 3 pi by n. Let's apply k is equal to 2m. So I will write 4 pi over n. This will be equal to 2m pi plus minus 1 raised to the power 2m times 3 pi by n. Minus 1 raised to the power 2m. This value will be always 1. So I can write 4 pi over n. It is equal to 2m pi plus 3 pi over n. Now 3 pi over n I will take to LHS. So 4 pi minus 3 pi over n. This will be equal to 2m pi or pi over n equal to 2m pi. Pi will be over. So 1 over n equal to 2m or n is equal to 1 over 2m. This is for k equal to even. Let us apply m equal to 1, 2, 3, 4. So n will be equal to 1 over 2m. For m equal to 1, this value will be 1 by 2. M equal to 2, 1 by 4. M equal to 3, 1 by 6. M equal to 4, 1 by 8 and so on. So here we will be getting non-integer values. Hence we can reject it as we are looking for integer solution, positive integer. Now I will consider the second case, k equal to odd, 2m plus 1 consideration. Let's apply to this equation 4 pi over n equal to k pi plus minus 1 raised to the power k 3 pi by n. Let's apply. So we can write 4 pi over n equal to 2m plus 1 times pi plus minus 1 raised to the power 2m plus 1 times 3 pi over n. Now minus 1 raised to the power odd. This will be always negative 1. So I can write 4 pi over n equal to 2m plus 1 times pi minus 3 pi over n. So I will take this term to the LHS. So it will give us 7 pi over n equal to 2m plus 1 times pi. Pi will be cancelled out. So I will write 7 over n equal to 2m plus 1. So n is equal to 7 over 2m plus 1. Now I will apply the values of m. Let us apply m0. So I will be writing here n values. 7 over 1. m1. 7 over 2 plus 1. 7 over 3. m2. 7 over 4 plus 1. 7 over 5. m equal to 3. 7 over 6 plus 1. So 1. And 1 is not accepted. N cannot be 1. If I will increase the value of m 4, then it will come out. Denominator will be bigger. So every time we will get fractions. 7 over 9, m equal to 5, 7 over 11, m equal to 6, 7 over 13, and so on. So these value will be rejected one. So only n equal to 7 will be accepted as positive integer. So our answer will become n equal to 7. I hope friends you will like this video. Thank you so much for watching. Do not forget to like, share and subscribe. Bye bye till next video. Good luck. Take care of yourself. Goodbye.